Hi everyone. Today we'll be talking about the wave function, which is a fundamental concept in quantum mechanics. Now, here we have a particle which has wave properties, and the wave properties can be represented by a wave packet. And if we have a wave packet, it can be represented by a wave function from which we will be forming the Schrödinger wave equation. Now the symbol for representing a wave function is psi, and mathematically it represents the particle. And a psi is the wave function is a function of x, y, z and t. For convenience, many times we will just take a one-dimensional case and present them as the psi as a function of x, which is a one-dimensional wave function. Now we need to understand what are the properties of a wave function. It is a complex quantity. It does not have a direct physical significance. But if I take the modulus square, that is the probability that is proportional to the probability of locating the particle in space. So if I want to calculate the probability of finding the particle between the limits x1 and x2, if I can just write that as p x1 x2, if I have to integrate this between the limits x1 to x2, psi square dx, this will be the probability of finding the particle. Now, one important condition is the normalization condition. Basically what it means is that because of the fact that it is related to the probability, the wave function is said to be normalized if integration of that, the modulus square, over the whole space in which it is defined, the whole integration is equal to 1. This is the condition for normalization. It is a very useful condition. Okay. So the properties of psi, one of them is that it has to be single valued. It is a continuous function, and the derivative of the psi function is also a continuous function. And also the fact that psi square is representing the probability, if the whole probability over the whole space minus infinity plus infinity, dv is the integration over the whole of volume dx dy dz, or if it is a one-dimensional case, instead of v we just have a x. If this is 0, that means the particle does not exist. And if it is equal to 1, the particle definitely exists. Another thing, if it is equal to infinity, the particle will be existing everywhere at the same time, which is somehow not possible. So this case we will not see. Then the psi square, because it is a probability, it will not be negative and it will not be complex. It will be a real number. And also the wave equation formed from the wave function psi, it is known as the Schrödinger wave equation. It is the fundamental equation which plays the same role as Newton's laws in classical physics, and it contains all the information about the particle. Thank you.